And if it looks like an intimidating problem, the reason we make a substitution is so it doesn't look so intimidating. And again, the key is going to be, if I go to this right here, and if I were to square it, it's the guy in the front. So the key is to find these, I call them blobs, but these groupings that are identical. So that's the pattern. So that u is going to be x minus 10 over x. And then if I square both sides, it's going to be that set of parentheses squared. So wherever I have an x minus 1 over x, the quantity squared, I'm going to put u squared. And where I have x minus 1 over 10, or 10 over x, I'm going to put u. And now that's not so intimidating. That problem is doable. The one above, because it's got so much stuff going on, it can be a little scary. This factors into u plus 9, u minus 1, or 3, I knew that. I know that. So that u is minus 9, u is plus 3. Now I need to take my solve for the variable, and I need to break him in half, because I've got two problems to solve. I've got that u is minus 9, and I have that u is positive 3. If u is minus 9, well, u was x minus 1 over x, or 10 over x. So that says x minus 10 over x equals minus 9. U is 3. That says that x minus 10 over x equals 3. Now this gives you a little review of the stuff that we didn't cover that is part of the extra credit stuff. Now this is just a rational equation, so you're going to clear the fraction and you're going to multiply both sides by the common denominator, which is x. So in this instance, you're going to have x times x minus x times 10 over x equals minus 9x. You notice here the x's reduce out. So you get that x squared minus 10 equals minus 9x. Now what do you do? I can't factor it yet. Bring the 9x over. So x squared plus 9x minus 10 equals 0. Now I have everything on the same side, 0 on the other, because it's a quadratic. So I could either factor or use the quadratic formula. Well, it does factor. But plan B should always be the quadratic formula. And I need a plus 9. So I get that x is minus 10, x is 1. Now I get to do the same thing with the other side. Multiply both sides by x. So I'll have x times x minus x times 10 over x equals 3x. Here the x's reduce out. So I have x squared minus 10 equals 3x. Again, I can't do anything until I bring everything to the same side, 0 on the other. minus 3x minus 10 equals 0. That factors x and x, 5 and 2, minus and plus, so that x equals 5, x equals negative 2. And the question is, do I need to throw any of my answers out? Well, let's take a look at the original problem. The original problem was x minus 10 over x squared plus 6 times x minus 10 over x minus 27 equals 0. What's the only thing x can't be? X can be negative, that's not going to be a problem. But what do I see I have? What is this thing called? A denominator. And what do I know about denominators? The denominator can't be 0, which means that x can't be 0. Do I have 0 for any of my values? No.